Alright, what's up and welcome back to Genuine Tutorial, and for today's video we're going to talk about differential equations under the topic of Bernoulli equations. Okay, but before we proceed, please don't forget to click the like button and also hit the subscribe button and the notification bell for you to be notified in our latest and future uploads. Okay, in Bernoulli equation we have the standard formula, standard form of a dy over dx plus y multiplied by the p of x is equal to y raised to n multiplied by the q of x, where the n here must not be equal to 0 or 1. Okay, remember that this Bernoulli equation is a nonlinear equation where we need to reduce it, or we need to convert this nonlinear equation to a linear converted equation. So this linear converted equation need a little bit of substitution. Yes. So today I'm going to show you how to reduce from this form to this form. Okay, let's add one page here. Okay, remember that the standard form of the Bernoulli is dy over dx, okay, plus y p of x, okay, is equal to y raised to n multiplied by the q of x. Okay, multiply the whole equation into 1 over y raised to n, so that is equal to dy over y raised to n dx plus y over y raised to n p of x is equal to y raised to n over y raised to n is equal to 1. So that is equal to q of x. Okay, the y over y raised to n is also equal to y raised to 1 minus n, where the y raised to 1 minus n is just equal to z. Okay, so let us derive the z with respect to y. So dz, the dz over dy is equal to 1 minus n multiplied by y, that is the quantity, right, raised to 1 minus n minus 1. 1 minus 1 is equal to 0. So the dz over dy is equal to the quantity of 1 minus n multiplied by y raised to negative n, or equal to 1 minus n over y raised to n. As you can see, we have dy over y raised to n. We have dy here, we have y raised to n here. So we can say that the dy over y raised to n is also equal to dz over 1 minus n. So a little bit of substitution, we have dy over y raised to n is equal to dz over the quantity of 1 minus n dx, okay, plus y over y raised to n is equal to z. Z p of x is equal to q of x. So from this form, let us multiply the whole equation into quantity of 1 minus n. So that is equal to dz over dz, that's not dz, dx plus z p of x multiplied by the quantity of 1 minus n is equal to the q of x multiplied by the quantity of 1 minus n. Okay, where the quantity of 1 minus n multiplied by the p of x is equal to the reduced function of p, j p r of x is equal to the reduced, this is equal to the reduced function of q. As you can see, dz over dx plus the dr of x is equal to the q r of x. Yes, they are the same now. Okay, so from the first order linear equation, we have also z multiplied by the phi is equal to the integral of phi, okay, multiplied by the reduced function of q dx plus c, where the phi here is equal to e raised to, okay, sorry for that, e raised to the integral of pr of x dx. Okay, so that's it. For you to fully understand it, let's all have an example. Okay, for example number 1, we have 2x dy minus y multiplied by the quantity of x plus 1 dx plus 6y cubed dx is equal to 0. Okay, for the first step, we will modify this equation into the standard form under the Bernoulli equation. Remember, we have dy over dx plus y p of x is equal to y raised to n p of x. So As you can see, we have 2x here, dx and dx. So we will multiply this whole equation into 1 over 2x dx. So the outcome is dy over dx minus y multiplied by x plus 1 over 2x, okay, is equal to 6 divided by 2 is negative 3, right? Since we already transported this one to the other side, this will become negative. So negative 3y cubed over x. So this is already the standard formed under the Bernoulli equation, where the p of x is equal to this quantity. So x plus 1 over 2x, right? And the q of x is equal to negative, okay, x, 3 over x. By the way, don't forget the negative sign here. So this is already included. So the p of x is equal to negative x plus 1 over 2x, and for the p of x we have negative 3 over x. For the n we have this one, negative 3. So the 1 minus n is equal to 1 minus 3, or 1 minus 3 is equal to negative 2. So this a is equal to y raised to 1 minus 2, or y raised to negative 2. Okay? For the linear equation, since we have already these givens, by the way, we have the reduced function of p. Reduced function of p is equal to the p of x multiplied by the 1 minus n. So that is equal to negative x plus 1 over 2x multiplied by negative 2. So that is equal to negative multiplied by negative is positive. 2 over 2 is 1. So the PR of x is equal to x plus 1 over x. So we can see that this is also equal to 1 plus 1 over x. Okay? So the reduced function of q, we have negative 3 over x multiplied by 1 minus n is negative 2. So this is also equal to negative 3 multiplied by negative 2 is positive 6 over x. Okay? So under the linear equation or linear converted equation, we have dz over dx plus z, the reduced function of p, is equal to the reduced function of q. We have dz over dx plus z multiplied by the reduced function of p is 1 plus 1 over x is equal to the reduced function of q is 6 over x. Okay, take note, under the first order linear equation, we have z multiplied by phi is equal to the integral of phi multiplied by the q r of x dx is equal to equal, okay, plus c, where the phi is equal to e raised to the integral of pr of x is to the integral of pr of x. So 1 plus 1 over x dx. So that is equal to e raised to the integral of 1 is x plus the integral of 1 over x is ln x. So we can say that this is also equal to e raised to x multiplied by e raised to ln x, where it is also equal to e raised to x multiplied by x, or x e raised to x. So the phi is equal to x e raised to x. Okay, the next step is to substitute the given values. We have z is y raised to negative 2 multiplied by the phi is x e raised to x is equal to the integral of the phi x e raised to x multiplied by the q r of x. Q r of x is equal to 6 over x dx plus c. Okay, x over x is equal to 1. So this is also equal to the integral of, okay, 6 integral of e raised to x dx plus c. So x e raised to x over y squared is equal to 6 multiplied by integral of e raised to x dx is also equal to e raised to x plus c. Okay. Okay, to simplify this one, we need to multiply the whole equation into y squared. So the outcome is x e raised to x is equal to 6y squared e raised to x plus c y squared. Okay, so and then divide natin into e raised to x. This will cancel out. This also cancel out. So the outcome is x is equal to 6y squared plus c y squared e raised to negative x. Factor out the y squared multiplied by the quantity of 6 plus c e raised to negative x. So this is the final answer.